A very warm welcome to all my dear students and friends. A very good morning, good afternoon, good evening. Welcome to this DADM 1 course under the NPTEL MOOC series, and we are for this course which deals only with statistics, multivariate analysis. Later on obviously these will come, and this is a 12-week course for 30 hours each week. As you know, you have 5 lectures each for half an hour, and this is the 12th one. That means we are in the 3rd week, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember the last slide or the last concept before we closed, the 11th lecture was related to central limit theorem. So, the central limit theorem basically says that considering any distribution with a certain mean, certain variance. So, we are only dealing with the first moment and the second moment, it can be done for other cases also. And we want to find out what is the sum, the expected value of the sum and the average of the sum, and in the long run what is the expected value of that. So, we found out that for the case if it is normal, then the mean value is mu for the average of the sample. Sample means the number of observations which you are picking up from 1 to small n, and the variance for that sample is sigma square by n, where again a small n is the sample size, sigma square is basically the population variance. Now, considering x bar n as a random variable, obviously it has to be because it has got a mean and a variance, then its corresponding distribution, as we told that if the population is normal, the sample distribution for the mean value is normal, mean value. I am not talking about the distribution of the variance. So, the mean values of the sample distribution is normal. So, when you convert that to a standard normal deviate with the mean value of 0 and variance of 1, then actually the conversion is like this. I am just saying that, listen to it carefully. In the numerator you have x bar n minus mu, because that mu is the expected value of x bar n, divided by, generally it is basically the standard deviation. So, what is the standard deviation in this case? The variance is sigma square by n. So, the standard deviation would be sigma by square root of n, and that would be normally distributed with 0 mean and 1 standard deviation. Now, in the case of sampling, so we are going to the realm of sampling. We will consider the 3 different ideas. These are very broad ideas, but I will just stick to the bare minimum as required. One is the point estimation, concept of point estimation, one is the concept of interval estimation, and one is the concept of hypothesis testing. So, what we mean by point estimation, interval estimation and point estimation, I will go through that slowly. Consider for the sampling, actually why you do sampling is that you have a population of capital N or infinite, and what you have about the information of the population is the population has a distribution, like it can be the geometric distribution, Poisson distribution, exponential distribution, hypergeometric distribution, negative binomial distribution, normal distribution, uniform discrete distribution, uniform uniform distribution, continuous one. Now, you have the parameters. So, the parameters for the normal one were mu and sigma square, for the exponential one was a or lambda or a or theta, whatever you imply. Poisson was lambda, for the binomial it was n and p, and all these parameters are there. So, we will denote the parameters in general by the theta. Theta can be either a vector or a scalar. So, if it is only one parameter, so consider like the Poisson distribution, theta is lambda. And if it is normal distribution, theta is a vector consisting of 2 elements, mu and sigma square. Now, if the parameters are known, we know the distribution in totality and we can do our work. But the question arrives that 2 things. Number 1, if we basically pick up a set of samples or observations of size small n, which means basically we are picking up observations x1, capital X1, remember that those are random variables. So, hence as I mentioned time and again in like in the beginning, so they would be given by capital X or capital Y or capital Z. So, they would be random variables capital X1 till capital Xn, and we want to find out the distribution of the characteristics of the sample. So, it can be characteristics can be mean of the sample, characteristics can be mode of the sample, characteristics can be median of the sample, characteristics can be variance of the sample, and there are many characteristics we want to find out, or some functional form also. So, given the parameters, we will try to basically do the study whether the characteristics sampling distribution is available to us, point 1. Point number 2 is that given the parameters are unknown from the population, how we can estimate them. Estimate means find them as close as possible using the sampling information. That means, the sampling information being from capital X1 to capital Xn, such that we are as close as possible to the parameter value, provided we meet few criteria. So, obviously, what are those criteria? I will come to that also. So, given a population of capital N denoting size, population distribution would be given with the parameters known. If they are not known, you have to find out, as I said in the just few seconds back. Now, the corresponding sample which you pick up, as I said, capital X1 to a capital Xn is the sample of set of observation, and it will have a sampling distributions. And the corresponding statistic which you see here on the slide, which is small t suffix n, that is the characteristics corresponding to the population parameter which we want to find out using the sample, such that the sample statistics T n is as close as possible to the population parameter. So, we want to find out that what is the characteristics T n from the sample, such that it is as close as possible to the mean value of the distribution, or else we want to find out that what is the sample characteristics from the sample, obviously from the sample, which is as close as possible to the median of the population, or you want to find out that what is the sample characteristics T n. So, T n is obviously changing, which is as close as possible to the variance of the population. So, we will try to study not in details, just as relevant to this concept of DATM. So, consider an example, very simple example. There are a lot of rigidity in how we are trying to consider the example, but it will give you a feel that what we are actually looking at. Rigidity, by the word rigidity, means that we are not assuming all the things to be true, but in a very in a naive sense, in a very theoretical sense, this is the situation, and how we can attempt, considering what I discussed about the statistic, the sampling population, considering the parameters being known, not known, whatever it is. Consider a population having a falling elements 1, 3, 6, 7. So, obviously, rigidity being that capital N is 4, which is not possible, but we are considering that. So, hence capital N is 4, and the mu value would obviously be, because if they are 4, the corresponding probability, we will consider the corresponding probability would be uniform. So, the probabilities are 1/4 for 1, 1/4 for 3, 1/4 for 6, 1/4 for 7, hence the mean value is 17/4. Now, what we do is that we take a sample size of n is equal to 2. So, n is equal to 2. So, we choose the samples in this way. So, we could have, obviously, we will consider that we are choosing, in the theoretical sense, the sampling are done in such a way that if you pick up number 1, you still have number 1 from the population to pick up in the second trial. Actually, that is not true, because if you pick up 1, the chit marked 1 is not there. So, we will consider this sampling being done with replacements. So, the total number types of samples we can have with 2 observations in the sample can be, in one extreme it is 1 1, because you can pick up 1 and then again you pick up 1, and in another extreme you have basically the sample or the observations as 7 7. So, this is what it says. Let me continue reading it and choose the samples, then hence the possible values of the samples averages, because if it is 1 1, so it will mean 1 plus 1 divided by 2, which is 1, and if it is 7 7, it will be 7 plus 7 divided by 2, it is 7. So, whole set of average values for sample of size 2 would be starting from 2 to 7. Now, obviously, they are the actual realized value for the sampling distributions average value which you are talking about, and if it is a distribution, we would like to find out what is the mean, what is the distribution parameters, so on and so forth. Now, simple sampling can be of 2 types, as I said. One is the sampling, sorry, my apologies, it's just went here and there the slides. So, sampling can be of two types, one is simple random sampling with replacement, which is SRSWR, and simple random sampling without replacement, which is SRSWOR. That means, we do with replacement without replacement. So, what I mentioned few minutes back, when you have that population of 4, if you are picking up observations and if you are doing with replacement, hence the corresponding probability distributions or the probabilities for picking up any observations does not change. As for the case, if you pick up 1 and if you consider that the number 1 is also present in the population the next time and the next time and so on and so forth, hence the probability always remains 1/4. So, it is simple random sampling with replacement. For without replacement, the probability of picking up 1 twice is 1/4 for the first time, and the second time it is 0/3, because there is no 1 and the total number of such observations the population has decreased by 1, hence it is 3. Note that if x has a distribution such that the expected value of the distribution is mu suffix x, mu is again nothing to do with the normal case, variance is sigma square suffix x, again nothing to do with the normal case. Then as I said in the last class, which is the lecture number 11, if you pick up any observations at random xi is the ith place you are going to pick up. So, the ith place can be filled up by any one of the observations from the population corresponding to the probability it has. So, if you want to find out the expected value of that ith place, which is exi, it will be equal to mu, and the corresponding variance of xi would be sigma square suffix x. Now, remember one thing, if I want to find out something to do with the covariances which I said, so that would basically be taken into consideration when you find out the covariances. So, before I go into trying to basically describe very briefly though the probability sampling, the simple random sampling on all these things. So, let me come to the concept of the covariances, which I did not go into details, but I will just mention it here. So, consider, let me use the red color, yes. So, what you have is basically these x1 and x2 are the random variables. So, the random variables I will denote by small x1. The first one is basically corresponding to the random variable number, the next one is the reading number. So, this will be 2, 1 and it continues to 1, n. So, this is the number of observations which you are picking up. This is the n is the number of observations you are picking up. Now, if I want to find out and consider this is a large set of values. So, if I want to find out the expected value, so the expected value of Ex1 we will consider is given by. So, these are just the samples which I have picked up. So, let me highlight it with some other color. So, these are the set of samples which I picked up. So, let me go back to the discussion. So, this is given by 1 mu suffix 1, this is given by mu suffix 2, variance of x1 is given by sigma square 1, variance of x2 is given by sigma square 2. So, note this down and then I will proceed. So, this is the background and I will erase it, but I will basically now come to the concept of covariances and then again come back to whatever is typed on the slide. So, I will erase it. So, this part which is highlighted, let it continue remaining, because whatever I have written about mu 1, mu 2, sigma 1, sigma square suffix 1, sigma square suffix 2 are for the population. Now, covariance between x1 and x2 would be given the relationship which is between x1 and x2. So, I want to find out the covariance, it will be x1 minus mu 1. So, this E is the expected value. So, multiply. So, there is no space, I will continue in the next line, x2 minus mu 2. So, actually what I am doing when I am trying to find out the corresponding covariances, so expected value would mean integration on the summation. So, if there are two variables, it will basically double summation. So, what I am doing is double summation for the discrete case for all x I value x 1 values, for all x 2 values, for the case when I have x 1 minus mu 1 into x 2 minus mu 2 multiplied by the case when I have the probabilities. So, these are the joint probabilities. I am going to come to that details later on, do not be too much bothered about that. And in the case when you have the continuous case, it is double integration, and in this case probability gets replaced. So, this will become f, this capital F, or let me put it as small f. So, capital F would be difficult for us to understand immediately, I will come to that. Small f f, but now it is a joint distribution of x 1 and x 2. So, it will be x 1 comma x 2 dx 1 dx 2. So, this is integrated for all x 1 comma minimum x 2 comma minimum. So, this is the minimum, the maximum value x 2 comma maximum x 1 comma maximum. So, you can find it. Now, if you want to find out the relationship, covariance obviously is important. So, when I basically do the covariance part, I will erase it again. I will come to those all details later on also. So, what I am trying to find out is basically the correlation, that is the relationship between x 1 and x 2. So, that is given by covariance. So, I am just writing the bracket, this covariance between x 1 and x 2 divided by the square root of variance of x 1, which is the standard deviation of x 1 divided by standard deviation of 2. Now, if I look at the covariances between two random variables, so how would they look like? So, and obviously remember, it can be proved that the covariance, I am not putting the suffix, it can be between any two random variables, is always this. So, inclusive of minus 1 and plus 1, it is always this. So, let me draw simply the diagram to make you understand. So, I will use the red one, so black one to draw the coordinates. So, the coordinates are, I am basically plotting x 1 along the x axis, x 2 along the y axis, and now I will try to denote the correlation coefficient, the rho value corresponding to the case when it is negative, it is 0 and it is positive. So, I will use 3 different colors. The first let be for the negative one. So, if you find out the negative one, generally they would be plotted like this. So, the general trend line would be in this direction. If I plot the positive one, I will only draw the trend line for the positive one. So, these dots would be there. So, the positive trend line would be something like this, and if I do for the 0 case, that means correlation not there, let me use the color green. So, they are everywhere. So, obviously, they are spread over along the 4 quadrants such that you cannot say what is the correlation value, which is almost equal to 0. So, if I basically consider the correlation coefficient, it will give me what is the relationship. So, now the correlation coefficient is 0.5, it would mean the rate of change of x 1 and x 2 is of 1 unit to half a unit, and if it is minus, it is 1 unit, it is minus 0.5, it is 1 unit to minus half, which means if it increases, for the negative case, if it increases, the other decreases. Now, consider that correlation coefficient values and the covariances. So, first let me consider the correlation coefficient values for n number of random variables. So, this n has nothing to do with the sample observations, small n. So, again let me erase it. So, I am spending a little bit time here. So, I am sure you will bear with me. So, let me draw, okay, yeah, let one at a time continuing it. So, now come back to the sampling which I have drawn. So, consider there are random variables till x n. So, these are given by x, oh my mistake. Let me consider this n as m, let me consider it as m. So, it is m 1 till x m n. So, m number of random variables, each being set of n number of observations, m as in mango, n as in Nagpur. Now, I want to find out the variance, covariance or the covariances between them. So, if I use that formula which I just stated, how you find out the covariances between two random variables, and when I write them, it is basically an m by m matrix, because there are m observations. So, I try to find out the covariances between the first, the second, the first, the third, the first, the fourth, the first and the last. Then I find out between the second and the third, second and the fourth, second and the fifth and second and the last. Similarly, as I continue doing it, I find out the m minus 1 and the m 1, and I basically find out the all the covariances. Now, when I am doing that covariances, obviously you will ask the question that what if I am trying to find out the covariances between two different random variables, would not the covariance also exist between themselves? Answer is yes, they will exist, but we have already considered that the covariances of a random variable with itself is the variance. If you put on the formula, what you have actually is, when you are trying to find out, it is basically x minus mu whole square. So, if in the case for the covariances, if it is the formula is x minus mu whole square. So, in the case when it is a covariance between two different random variables, it is x minus mu 1 into y minus mu 2. Hence, when both x and y are same, hence mu 1 and mu 2 would be same, then we get the variances corresponding to the covariances, where the covariances are between the same random variable. So, now when we write the m by m matrix, that is mango, m is mango not n as in Nagpur, the m by m matrix, actually this denotes the following. Let me erase the part, else it gets, this should be there. So, the first variable which is 1 comma 1 cell is sigma 1 1, which is the covariance of the first with itself. The second one along the row is a sigma 1 2, which is the covariance of the first to the second, and I continue doing it till the last one, which is the covariance of the first with the mth one. Now, I come to the second row. The second one is sigma 2 1, which means there are mirror image of 1 2 and 2 1, because trying to find out the expected value of x minus mu 1 multiplied by y minus mu 2 is equal to the same thing, finding the expected value of y minus mu 2 into x minus mu 1. Second element on the second row is sigma 2 2, which is basically the variance of the second, or as I can say, put in another word, is the covariance of the second with itself. I continue doing it. So, if I go to the last element, it is m comma m 1, and the last one is m comma m. So, this is the variance covariance matrix. For the population, you will have a variance covariance matrix for the sample also. Similarly, when I come to the correlation coefficient, so variance covariance matrix I will denote by this for the population, and this gets replaced by the variance covariance matrix corresponding to the sample as capital S, these are capital S. When I replace and try to find out the correlation, so let me remove this whole part, everything let me remove, I will again draw it, so it will become easy for you. So, now I am trying to draw the correlation matrix for M cross M. So, first element obviously correlation is basically of the first random variable with itself. So, that relationship is 1. The second one is basically the correlation of the first to the second, and similarly the last one is this. The second rows are accordingly. So, correlation 1 to 1 are symmetric. So, they are same. The second element is 2 because the correlation of the second with itself is 1. Similarly, this last element is this. So, the principal diagonal, let me highlight it. Yes, the principal diagonal is 1 and the of the diagonal elements are the correlation coefficient which is symmetric. So, that is denoted by in the case for a population weight for the population, and when it is the sample it is denoted by R. So, I think I can erase this part. I even if the slide is being shown here, I will discuss these details of simple random sampling and all these things more detail in the next class, because I thought it was important. So, hence I am going a little bit slow and I hope you are understanding it. Now, coming back to the observations what I have written down. So, if you remember I put a yellow highlighted here. So, there was a reason. Now, when you have a sample and you want to find out the correlation coefficient, covariances and all these things, what you do is simply you consider the sample, consider the averages of the sample as such. So, they would be the sample averages. So, the sample averages would be given as x bar 1, similarly till the last one is x bar m. So, for this is for this. The variances would be given by S1 square, I will come to that later on, Sm square. So, they would be discussed in detail within few class, and the correlations would be found out. Find out the averages here. So, they would be sample averages given here. Find out the covariances, which the word is not covariance, it basically square of standard error or the variance of the sample. So, they would be given here, and you can find out the corresponding correlation coefficient and the covariances also. With this I will end the 12th lecture, but the slide which is in front of us, I have not discussed anything about probability sampling. This I will only discuss in a qualitative framework. I will come to that in the 13th lecture and correspondingly other lectures. But remember, when I have been talking about the correlation coefficient, covariances, mean value, standard deviations for the samples, corresponding to the case we will be discussing the sampling distribution. I will again come back to that in much further details. Have a nice day. With this I will close this 12th lecture, and thank you very much for your attention.